Assalamualaikum. Hi. In this presentation, we will take a look on topic 5, the last topic in the Reaction Engineering 2 subject. So this topic is being divided into two parts, which are part 1 and part 2. So in this part 1, we'll take a look on the growth kinetics in batch culture and how the environmental conditions affect the growth of kinetics, and the growth kinetics in continuous culture, and also the mass balance for cell growth from the continuous model, and we may able to determine the kinetics parameters for cell growth from model equation, and the transport processes in stirred tank bioreactors. The textbook that being used for this topic is Bioprocess Engineering Basic Concepts, second edition by Prentice Hall, written by Schuler and Cargie. You can read in chapter 6. We'll start with the bioreactor. So what is bioreactor? Bioreactor is a vessel in which is carried out the chemical processes. Specifically is the biochemical process, which involves organism or biochemically active substances such as microbes and enzymes, which can be derived from such organism, such as enzymes, in order to produce bioproducts. For example, in the production of ethanol, or also known as a bioethanol, because we're using the yeast as the organism and glucose as the chemical substances, which is known as a substrate. In the bioprocess, you need a substrate for a cell to consume in order to produce bioproduct. The types of bioreactor are the batch bioreactor, which is also known as a batch culture, the continuous stirred tank bioreactor, or also known as chemostat, the continuous culture, and also we have a plug flow bioreactor, which is also known as a continuous culture. You can design a bioreactor system if you know the stoichiometric equation of the conversion for the bioreaction, and if you know the rate of the conversion bioreaction, and if you know what variables affect the rate of the conversion bioreaction and in what way. So how cell grows? Because we are dealing with the cell or microbes here. So how cell grows in order to produce the bioproduct? First of all, what bioreactions are involved in the production of free microbial cells? It is growth. Growth is important in the bioprocess. So the rate of growth is directly related to the cell concentration. So this cell concentration, it can be measured in the form of cell number or in the concentration wise, milligram per liter, right? Such as that. The rate of microbial growth is characterized by the net specific growth rate, defined by dx over dt mu net times x, or if we rearrange this equation, it will become mu net equals to 1 over x dx dt. This is the general equation for the growth rate of the cell growing. The microbial growth can also be described in terms of cell number. So here, the difference is only in terms of the abbreviation used, which is x and n. So it will be 1 over n dn dt. But most of the production, most of the experimental work being done, we use x, the cell concentration, as our units, our form of in order to identify the rate of microbial growth. The cell growth is the primary response of viable cells to substrate and nutrients. the product formation will be a secondary response. So now, before we can produce a bioproduct, okay, what we do? What is the first step that we have to do? Okay, so the answer is we need to grow cell. Okay, and therefore we need to understand on how the cell is growing and the underlying concept of the growing of the cell. And how do the cell grows? Of course, we need to feed the cell with food, which is known as a substrate. Okay, for example, just now bioethanol, the substrate is glucose. So you need to identify what kind of substrates, effective substrate, suitable and appropriate substrate to be given to the cell. And this is the stoichiometric equation of the cell growth, okay, which is written here, S plus X equals to P plus NX is the number of cells. Okay. Alright. So as you can see from the equation, okay, microbial growth is an autocatalytic reaction. So what is autocatalytic? We have seen these autocatalytic terms in the chemical reaction. But what is autocatalytic in the growing of cells? So from the equation itself, okay, you can observe, okay, it is because not only we produce the bioproduct itself, but we also grow cells, more cells that would enhance the production of more bioproducts in our production. Okay, so the rate of growth is directly related to the cell concentration. Okay, and the cellular reproduction is normal outcome of the reaction. Okay, let's take a look on the growth kinetics of microbes or microorganisms. So the model growth kinetics is represented by the Monod equation, which is mu equals to mu m. Mu m is the mu max, the maximal specific growth rate. Okay, S is a substrate over Ks is the saturation constant plus S. Okay, this saturation constant, okay, is equivalent to S value substrate concentration when mu is half mu max, okay, or mu m. Okay, before we go further, we have to understand the phases of the growing of the cell or microbes. So the growing of the microbes, it starts with the lagging phase. You can see here lag phase, in which the kinetic rate, represented by specific growth rate mu, is equivalent to 0, nearly equivalent to 0. Then we have an acceleration, just a small duration here. Okay, acceleration where the mu will be less than mu max or mu m. Okay, this is the important part, which is the growth or exponential phase. Okay, so in this growth and exponential phase, the mu will be equivalent to mu max. Okay, so in order to identify the mu max, we have to use the data at the growth or exponential phase. Okay, later we have a decline or deceleration phase, which is mu is less than mu max. Okay, and then we have stationary, which is mu equals to 0. Okay, because there is no more growing. Okay, it becomes stationary here. Alright, and finally we have the death phase. Okay, where the rate is lower than 0. Okay, you have to remember all these phases because this is the general plot which need to be used in order to identify the growth kinetics of the microbes. Okay, because the production of the product, it can be at the growing phase, the exponential phase, or at the stationary phase. Okay. Alright. So let's take a look on the growth phase. The growth phase is also known as exponential phase, okay, where it is a first order rate of reaction. Okay. It represented by the equation of dx over dt equals to mu net times x, okay, or also mu equals to 1 over x dx dt. It's similar, just you rearrange the equation where this equation, okay, if x equals to x naught at t equals to 0, it starts with t0. Okay, then you integrate the equation, it will yield to ln x over x naught equals to mu net times t, or x equals to x naught exponential mu net t. Okay, so the time required, okay, for the microbes to double up is given by tau d, doubling time, okay, doubling time of the cell mass equals to ln 2 over mu net. Okay, you can calculate, you can determine the doubling time, okay, by using this equation. Okay. We're talking about mu net here. At the exponential phase, this mu net is equals to mu g gross, okay, gross specific growth rate, which is equivalent to mu max, the maximum specific growth rate. Okay, so remember here that the mu net is equivalent to the maximum specific growing rate of the microbes in during the exponential phase. So during this phase, there will be no involvement of endogenous metabolism. Okay, what is endogenous metabolism? Okay, this endogenous metabolism, it refers to the stage where the microbes of cell are trying to survive, are trying to repair themselves in order for survival. Okay, they use whatever they have in the surrounding in order to continue their living. Okay. Okay. How to find the maximum specific growth rate? Because this maximum specific growth rate can be identified from the exponential phase. So how to find it? From the slope here, you can see here, okay. Alright. You find the value, okay, of x1, x2, t1, t2. Then what you have to do is, okay, to find the mu maximum, this x value, if you have the graph of x versus t, you need to ln it, and okay, you over with the difference of time. So it will be ln x2 minus ln x1 over t2 minus t1. Then you may able to find the mu max of the growth kinetics for the microbes. Okay, so from the equation here, okay, you see that it is based on the slope of the graph at exponential phase. Okay, again I highlight the slope of the graph at the exponential phase. It means that if you're using the Excel, you need to plot only the data, the tabulated data at the exponential phase. Then from the linear line equation, which is represented by y equals to mx plus c, then you just only take the slope of the graph.